For part 1 of the question, we are asked to differentiate ln x over x. So we will use quotient rule to approach this. So dy dx is v, so v is x. Du dx, so we differentiate ln x, giving us 1 over x, minus, now we keep ln x, differentiate x gives us 1, over v squared, which for this case is x squared. So a bit of simplification, x times 1 over x gives us 1 minus ln x over x squared. And that completes part 1 of the question. So for part 2 of the question, we want to evaluate this definite integral over here. This is a hence question, so we definitely want to try to use part 1 in our working. So how can we use part 1? In part 1, we found that the derivative of ln x over x happens to be 1 minus ln x over x squared. So with the understanding that integrals are the opposite of derivatives, the integral of 1 minus ln x over x squared would be ln x over x. So this is the key idea we will have to use for the part 2 of the question. However, as it is, we can't really use this observation yet, because what we know is the integration of 1 minus ln x over x squared will be ln x over x. However, we are not asked to integrate this, we are asked to integrate ln x over x squared only. It's actually present over here, but we are missing the minus sign over here, and we're missing the number 1. So here we have to use some tricks to force 1 minus ln x over x squared out. The first trick we will use is the fact that multiplying 1 to an expression does not change it. And minus 1 times minus 1 happens to be 1. So multiplying two negative signs doesn't change our expression. So for our expression over here, we'll multiply a minus over here, as well as a minus over here, and the quantity on the left and the quantity on the right will still be the same. The next trick we will apply is the fact that adding 0 to an expression does not change it. So how do we add 0? 1 minus 1 happened to be 0. So we want to force this 1 out over here. So we add a 1 over here and subtract a 1 behind. So adding the 1 minus 1 is adding 0, so it doesn't change the expression. So the expression on the left and the expression on the right is still the same. So with this trick, we can now proceed with our integration by splitting up our integral. So we take 1 minus ln x over x squared, because that is the nice quantity over here, and we split up minus 1 over x squared. Now we proceed to integrate. Integration of 1 minus ln x over x squared, as we have discussed, is ln x over x. Integration of 1 over x squared is negative 1 over x. We bring the power minus 2 up by 1 to be power minus 1, and divide by minus 1. So we end up with plus 1 over x. Then the limits, upper limit e, lower limit 1. Now we sub in the limits. Ln e over e plus 1 over e minus, now we sub in 1, ln 1 over 1 plus 1 over 1. Okay, so ln e is 1, so we have 1 over e plus 1 over e minus ln 1 is 0, and 1 over 1, so minus 1. Simplifying this expression gives us the final answer of 1 minus 2 over e. And this is our final answer.